Welcome back for the actual hands-on troubleshooting. What we're going to start with is we've got the pump actually running right now, and I'm going to try and speak over the top of it, so hopefully that becomes clear. You can see the pump is running, so I should be registering pressure. And at this point, you can see the gauge is actually 0. So what I want to do is try and increase the pressure, so I'm going to go ahead and hold this switch in the up position. Now understand a TIR butterfly valve, it takes it about 15 seconds to move 90 degrees. There, you see the needle begins to rise, and it's rising. Now it fell off. So that's that point where it actually went over the top. But I can't get 20 PSI. So what I'm going to do, which is typical, is I'm going to go ahead and increase my RPM. Okay, this is great. I can get 40 PSI. So when I turn my booms on, so with all the booms on, it dropped down to 35. I've got to spray at 40, so I've still got a problem. Well, is it the pump? And I'll challenge you to say we need to look at the system differently before we jump on the pump. We want to narrow things down. Many systems are designed with this agitator or flow line that comes off of the pressure side. They'll have a spring-loaded pressure sensing valve that will basically open when the system hits a certain pressure. These springs, they do loosen over time, they do wear, they do have problems. So what we want to figure out, this is a simple quarter turn valve. I could easily turn it off to figure out if that's my problem. What I want to do is simulate that I don't have something this simple and I don't know if it's leaking through here. So what I'm going to do is simply take a shop towel or something to guard on the hose. Then I'm going to put channel locks on the hose, and then I'm going to begin to squeeze down. And I'm going to watch on the pressure gauge, and look at that. At idle, I've got 160 PSI. I've just basically told myself the pump is good to go. I've got something that's bypassing through this pressure line, or through this agitator line. So now I need to look at this valve if I don't have a simple quarter turn valve. Now the same troubleshooting, if you don't have this or you suspect the pressure regulator is bad, we can go ahead and close this down. So we're at 40. I'm going to intentionally drop the pressure on the pressure regulator to simulate that you think that the pressure regulator is bad. And then simply doing the same thing on the return line. I can raise the pressure back up. So that would indicate that possibly there is something wrong in your pressure regulator and everything is bypassing going back to tank. Another way you can look at it is this way, which is I've got a full flow going back to tank. As I close my pressure regulator, you'll see the flow begin to diminish. So now I can see I've got just a trickle going back to tank. So this is another way visually that you can actually troubleshoot and see what's going on with your system. So those are the main things to actually troubleshoot. But again, looking back at the path of least resistance, where your fluid flows, something like this. It's going to flow through here before it builds pressure in here. I need to block the flow here. It's going to flow through here before it's going to go out of your valves here. So I need to start building or making the pressure there. Now, if you have pressure at these points and it's not coming out at your booms, then you need to start isolating. Is it coming out? Loosen these. Drop the hose down. Is the valve flowing out? And you move on down and you start isolating the sections where you know you've got flow or pressure and figure out, does the next section have it? Work from the pump, go out to the valve tips, and you will eventually find the problem more times than not. Thank you.
Texas Industrial Remcor, quality valves and controls today and tomorrow.